Hey guys, welcome back. I have a 2003 Hummer H2 here, like 90% through with the Diag. I haven't found the exact problem, but I'm very close and I want to catch you guys up to speed on what we're doing. So it was at another shop. Customer requested them to put a throttle body on. It had throttle body codes. They put a new OEM throttle body on. Still has the issue. He told me he can drive around the block a couple times. Goes reduced power and sets a bunch of throttle body codes in the system. He went through the trouble tree, resistance checked all the wires, tug tested the harness at the throttle body. I told him check powers and grounds to go into the module. And at that point, he didn't want to go any further or was wasting time doing it. So he dropped it off here. Let's go ahead and pull it up on the scanner. So this is the one code that comes back over and over. The 1518 PCM to TAC module serial data circuit. Now, this had a bunch of other codes. It had correlation codes for the TP sensor, the APPS sensor. I think there's about 5 codes. I think they're in my other scanner, but this code comes back repeatedly over and over again. So the first thing I did when I saw a COM code is I plugged in my picoscope OBD2 breakout box and hooked up the lab scope to the communication lines. Now, I haven't seen a lot of issues with class 2 GM serial data, so I was a little unfamiliar. I had to look at a couple known goods to make sure what I had was good. Let's go ahead and open the lab scope to look at that communication line. So my yellow channel is connected to pin 2 of my breakout box, and this is the GM class 2 serial data. Now we can zoom in our waveform here, look at our data, and kind of see what we have going here. It looks like we have 0 to 7 volts, which when looking at known goods or service information, that's what I'm supposed to have. I don't see any dropouts or glitches, but right now I'm not sure if the vehicle's acting up right now or not, but I figured out how to get the vehicle to act up in the shop. At one point it's stuck in the position where it was acting up. But a lot of times when I have communication issues, I want to make sure that I don't have excessive alternator ripple. I don't have a weird battery issue that's causing it. So I'm going to start it up. My channel 2 is connected to pin 16 of the data link connector, which is the battery power. I have the scope grounded to pin 4, which is chassis ground. So I'm going to go ahead and start up the vehicle. So we get a little more communication and activity on our class 2 data line. Let me AC couple channel 2, and we'll switch from 20 volts down to half a volt just to see how much ripple we have going on here. We can throw a couple cursors up on the screen. Let me shut this off. So we have a high point there, and we got a low spike here, but that could just be some system noise. We only have 100 millivolts between those 2 points. So our alternator ripple is probably not having a big impact on this communication. And actually our communications look perfectly fine. Actually, we're getting quite a bit of noise just having the key in the on position. Some of that could be going through the breakout box, but either way, our AC ripple is relatively low. So when I saw that, I didn't jump into any conclusions and assume that the alternator was causing our issue. So let's go back to our scan tool. And let's clear the codes out because it's in reduced power mode right now. And then let's open some data. And I just want to look at the throttle body data and see if I lose communication, if I end up with another issue, or if my TPS and APPS are not in sync. We're going to deselect everything. COM fault, reduce power, we'll leave those on. Let's see. Now, I didn't have any APPS correlation codes between 1 and 2. I only had them on the throttle body. And then there was a code for APPS/TP correlation. But if it can't determine what the TPS is at, then it can't determine if they're in sync or not. So it says my TPS is at 0 right now. Everything's 0, even the voltage is 0, the percentage is 0. They agree, it says yes. Reduce power, yes, even though we just cleared the codes. So right here on the screen, we can see that we had a reading for a little bit, and then it dropped back down to 0. My TP indicated angle went up to 100%. It says that we have a COM fault. Reduce power, yes. Desired angle is way low. It has a misfire. It's shutting off injectors probably to drop the idle down because it went to a preset position in that throttle body. So we definitely have issues here. So if we're having issues communicating with the throttle body or the TAC module, then why don't we have a bad waveform on the comm lines? Because that looks pretty good. Now, I'm not an analyst of any sort or a coder, and my Snap-on doesn't have decoding ability for that communication protocol. But that waveform looks fine to me. We can shut off the alternator waveform there that was making some noise. This communication line looks just fine. If I really zoom in, we can see, see what the actual signal looks like. And keep in mind, I have my scanner plugged in, which may affect the signal slightly. Well, let's look at the wiring diagram. So if we look at the communication wiring diagram, I'm in all data. I want to go to the OE diagram, and I want to go to communications, probably information bus. So this is the data link connector, power ground, DLC, and splice pack. So we have the splice pack right here in the middle of the screen. Now, most of our class 2 data is going to go to that splice pack. But what we want to see is if the throttle body module is connected into that splice pack or where it's spliced in. Because if so, we can tap into that splice pack, remove the comb that joins them all together, and we can actually check each individual module and see if we have a communication issue that way. But as I'm looking through this splice pack, I see, driver module, BCM, or driver door module, transfer case, EBCM, air suspension module. We have power, we have driver door module, HVAC controls. It shows where our power comes from. Pin 4 and 5, it shows where those are grounded. We have G203 and G200. But we don't have, in this diagram, our throttle module. So let's go to the next diagram. So this is 2 more splice packs and the dedicated TAC serial data connections. So rear seat audio module, so nothing in that one. We have a PCM and TAC module. So it shows that we have 2 data lines going between the PCM and the throttle actuator control module. So 2 data lines that are dedicated only between those 2 modules. They obviously want, rapid communication between those 2 modules without everything else clouding it up. Plus, if we have a communication fault on the main class 2 line and the vehicle's still running, they want you to be able to have throttle control. So we're not going to see this at the DLC, at the data link connector. So once I realized that the TAC module has its own communication between itself and the PCM, I jumped under the hood and started scoping stuff. So let's move out there and get set up once again. So the throttle actuator control module is located on the firewall right back there. I know it's really dark. See if I can shed some light on the situation here. We're having some focusing issues, but it's right there on the firewall. The left connector is the one that goes to the throttle body. The right one is all the data lines and powers and grounds and everything else. The other shop already had the loom peeled apart for easy access. The throttle body is there with the pigtail exposed. They did resistance checks on everything. They did a tug test on those wires because I told them sometimes those wires will break. About 6 inches from the connector. You got to peel the insulation back and give them a little tug. But that wasn't the issue. So we have two data communication lines. Now one says secondary, one says tertiary. Now there's only two lines going to the throttle actuator control. Now the reason that there's a secondary and a tertiary is that's on the PCM side only. It has other communication lines that go on the network for all the other modules. So I just want to tie into one of those, and then I also want to tie into the power and ground for the throttle module, just in case we have an intermittent glitch. And that's what I have the lab scope connected to. So I have, I'm pretty sure, okay, so I have channel 1 connected to the communication line, that orange and black that goes from the PCM to the throttle body. Green is connected to the TAC module ground, strobe in here. And channel 3 is connected to the TAC power wire. So what I want to do is, if I can get this to glitch out again, I want to make sure that I'm not losing power or ground to the TAC module. Whether it's a bad fuse block or ignition switch, if I lose power to the module, it's going to affect my communication lines of some sort. Either they might get pulled down to ground, they might get pulled up to power. So that's what I want to do. Now what I found is if I put a load on the steering wheel, if I start steering the vehicle, I can get this vehicle to act up. I noticed at first when I was backing it out of the shop to go on a test drive, as soon as I steered hard, it acted up. So we'll see if we can get it to act up. I'm going to change my time base a little bit here because I want to be able to capture some more data. I don't want to miss it. So I'll start it up, I'll steer it back and forth a few times. We'll see what the glitch does, if it happens, and then we'll analyze our data. Okay, so that didn't take long. I just started it up, I turned the steering wheel, and we had a glitch. So let me zoom out, and let's go to where that glitch happened and look at the information. So right where the center cursor is, that's where the voltage dropped on the power wire where I started it up. And then, like as soon as I let off the key, I just grabbed the steering wheel and shook it. And that's where we can see my yellow trace, where I had, a sawtooth pattern in the communication line, where that starts to follow our voltage line. So let's go over there, zoom in a little bit, and see, what's going on here. So over on the left on our yellow communication line, looks like 0 to 5 volts. So we're not seeing the same 0 to 7 volts that we were seeing before, but 0 to 5 volts. And then as soon as I touched the steering wheel, it jumped up to 12 volts. I could probably throw a cursor on there to make sure, but yeah, cursor number 1 is 11.1 volts. But that's the same as our battery voltage since I just cranked it over and it hadn't even started charging yet. So let me turn the cursors back off. But normally when you have a communication line go to power like that, it could be because you lost a ground. Well, we have the ground for the TAC module scoped, and according to this, we didn't lose a ground. Now we could have some terminal issue inside of the connector. I don't think that the internal ground of that TAC module is at fault, especially because when I came out here earlier, the throttle body was buzzing, which tells me that it's still powered up. It's still able to control it slightly. So we need to find out why, when I turn the steering wheel, we have communication issues. So I'm gonna fire it up and run it, and I'm gonna cycle the steering wheel left and right and see if we can get this glitch to come and go, see if it only happens at a certain position on the steering wheel, see if it happens only when I steer it fast or slow. And then we gotta find out why the steering wheel is related to the throttle body. So as you can see, just turning the wheel back and forth, we end up shorting that communication line to power. Now, I don't see any reason for that communication line to come inside the vehicle, but I did a visual inspection underneath the dash. I don't see anything rubbing the steering shaft. I don't see anything tied to the steering angle sensor. I even looked to see if there was a, variable speed valve or variable effort steering valve on the power steering pump. I don't see that. Early on, I did notice that it has the wrong plug wires. It has the longer plug wires installed. And this one does rub this, lock tab on the steering shaft. And I checked to make sure it wasn't arcing, because I thought, well, maybe it's just arcing it, sending a spark through there, and it's freaking out the modules and the communication lines. That's not the case. Now, if you do have these longer wires, you can normally just rotate the boot up like that. It'll shorten that wire about 1/4 inch and keep it away from the steering shaft. But these GMs have 2 different lengths of wires depending on what coil is installed. So, it really needs some shorter wires. Looking at the steering shaft, get some light in here. It's kind of hard to see, but that steering shaft is not touching any wires at all. So what else could be causing it? Why is the steering affecting our TAC communication line? Well, maybe we just need to start it up and start wiggling wires. Now that was one of the steps I did early on, is I wiggled the connector at the throttle body, I wiggled it at the TAC module, and nothing happened. I wiggled the main engine harness where it goes across, because there's power wires going to the throttle body, before I realized that it's just the TAC communication lines getting shorted. But let's go ahead and start it again and see if we can wiggle stuff around and find where the problem is. So our main engine harness, don't see anything there. Let's grab the steering shaft. I don't see any change there. PCM wiring. Well, we get a change there, but why would moving the PCM connector change what we're seeing on the TAC communication lines? And why would that be affected by moving the steering wheel? Well, I'll show you what I found. And I haven't taken the wiring apart completely here yet. Well, right down here is the power steering line. Goes from the pump up over here to the hydroboost, back there somewhere. So whenever I steer the vehicle, more than likely that line is flexing and moving. Well, it looks like it's leaking a little bit, but it's also right up against the wiring harness coming out of that other PCM connector. Now this PCM connector here, the wires come out the top. The other connector, they come out the bottom. Okay, I'm hoping the camera will stay put. I'm gonna go inside, turn the steering wheel back and forth, and see if it'll act up. So that little bit of movement in that power steering line, although it doesn't seem like much, is just obviously rubbed through one of the wires or more than one wire and is shorting out the communication line. Now, there could be other wires in there that are damaged as well. We don't really know what's happening to the PCM at this point, but we have a new throttle body, which we probably didn't need, but we know that that's good. The wiring's good. The TAC module seems like it's good. What we really need to do is pull that connector off of the PCM, lift that harness up, inspect it. Now at this point, since it came from another shop, I'm going to tell them what I found, where the problem is. We'll let them decide if they're going to let me fix it or if they're going to fix it themselves. If they let me fix it, then we'll either do a follow-up video or some bonus footage. So hopefully that gives you kind of a route to go. If you're having one of these issues, just keep in mind that the throttle body and the PCM have their own dedicated communication lines that are not tied to the rest of the system. Because even when I was tied to the Class 2 line and I was able to get it to act up, I didn't have any glitches on that line. But here we obviously have a glitch. And when I first scoped just the one communication line and saw that it was getting shorted to power, that's when I'm like, okay, well, I might be losing a ground on that TAC module. If I lose the ground, it can't regulate the powers. Sometimes it jumps up. Now, normally not all the way to full battery voltage. Sometimes it's, you know, it gets pegged at the higher limit of the communication line. But in this case, I'm like, well, you never know. So powers and grounds were good. Communication line getting pulled up. No obvious rub marks on the power steering shaft or in the column. If it was a regular Class 2 line, sometimes I would be concerned about, is the steering wheel position sensor or the steering angle sensor tied to the communication lines? And when I rotate that around, it's causing issues, but we didn't have codes in other modules. So I thought this was just kind of an interesting case study. We don't see a lot of the H2 Hummers around. I don't know if there's just not that many on the road or that many left on the road, or if they've just, you know, kind of fallen out of style in our area, but we see them every once in a while, and normally they break the wiring harness right near the throttle body, just like every other LS platform out there. But this particular case, it was something different and it was kind of interesting, so I figured I'd share it with you guys. If you have questions or comments, put those down below. I'll try to get back to you as quick as I can. If you want to see more videos like this, subscribe, click the bell. Thanks for watching. See you next time.